Welcome to Chapter 6, Section 2, which is all about absolute values and square roots. So first of all, let's talk about absolute values. If you remember, the definition would be the distance from 0. So no matter what your value is, okay, it's always going to be positive. So no matter what you put in, you always get positive because we're talking about distance, which can never be negative. So if we take a look at the graph, maybe we'll just start with an XY chart, and we'll say, okay, let's graph the absolute value of x. And the absolute value are just those straight bars around it. So maybe I'll plug in -3, -2, -1, 0, 1, 2, and 3. So the absolute value of -3 is 3, absolute value of -2 is 2, and so on. So if I go ahead and graph that, and if I go by ones, I've got -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So the graph of the absolute value is this V-shaped. Okay, and that will always be true. It's never going to come down here in the negatives because you can never have a negative answer. So it's always going to be positive. So if we talk about domain and range, domain, hopefully remember, goes left to right. So as I go left to right across this, I'm going to see the graph everywhere. So my domain is all reals. My range, which starts at the bottom and goes to the top, well, I only see the positives. So I'm going to say y is greater than or equal to 0. So that's what our graph looks like. Let's go ahead and answer some questions. So the absolute value of -12 minus 40 divided by 8. So let's remember our, please excuse my dear Aunt Sally rules. The first thing we would have to do is divide 40 divided by 8. So that's going to give me -12 minus 5. Okay, so you have to do this part first. So that's going to give me absolute value of -17, which gives me a positive 17 for my final answer. Okay, so always just dropping them at the end. That's the last thing you do. Okay, negative turns to positive. Now when I'm actually solving, like example B, now to drop the absolute value bars, you should remember that we have to write two equations. One to equal a +6 and one to equal a -6. Because no matter what the inside of this turns out to be, okay, if it's a -6, the absolute value bars make it a +6, so I will have two answers here. So if I solve my first equation, I'm going to add 6. So I get 2x to equal 16. Divide by 2, I get x to equal 8. If I solve my second equation, same step. This time when I add 10 to a -6, I get 4. So I get x to equal 2. So my answer is x equals 8 or 2. Okay, so if you kind of think about it and you plug it back in your equation, if I plug in 8, I get 2 times 8 is 16, minus 10 is 6. The absolute value of 6 gives me 6, so I know that one works. If I plug in 2, I get 2 times 2 is 4. 4 minus 10 is a -6, but the absolute value gives me a positive. So you're always going to have two answers here, okay? Just make sure you set up two equations, and you're always changing this number on the right side of the equation. So let's try example C. What's different now is that the absolute value bar is not by itself. So the first thing you have to do is get these absolute value bars all by themselves. So I'm going to move this 4 first, okay, by subtracting just like normal. So I get absolute value of 2/5 x plus 6 just equal 10. Okay, now that I have the absolute value bars by themselves, now I can make my two equations. So I'll drop the absolute value bars by setting equal to 10. Or my second equation, 2/5 x plus 6 would equal a -10. Okay, you cannot do the plus or minus number, okay, which is this number over here, until the absolute value bars are all by themselves. Okay, that's a really important note to make for yourself. So if I solve these, I'm going to subtract 6, so I get 2/5 x equals 4. Okay, and then I would divide each side by 2/5 here. So I get x to equal 10. For my second equation, I'm still going to subtract 6, but now when I subtract from a -10, I get a -16. I'll still divide by 2/5, so this time x gives me a -40. So I get 10 or -40. Again, if you want to check those in your original equation, it should come out just right, okay, which is kind of nice. You can always know if you're right or wrong. Let's try one more. Let's try example D. This time I have a lot of things, okay, surrounding my absolute value bars. Okay, so your goal is to get those absolute value bars, which are in blue, all by themselves. So first you're going to add your 3. So I'll have a half times 5x plus 6 to equal 18. And now you're going to get rid of the 1/2. Okay, so now I'm going to divide each side of my equation by half. So now I get my absolute value bar all by itself. Okay, make sure when you do 18 divided by half in your calculator, use parentheses because that should give you 36. Okay, so now notice my absolute value bars right here are all by themselves. Now, okay, and only now can I make my two equations, which will say 5x plus 6 equals 36. And my second equation, 5x plus 6 will equal a negative 36. Again, you're always changing the number on the equal sign, okay, after the absolute values are by themselves. So I'll subtract 6, so I'll get 5x equal 30, divide by 5, x equals 6. My second equation, this time when I subtract 6 from 36, I get a negative 42. Divide by 5 and I get a negative 8.4. Okay, so you've got two answers, x equals 6 or negative 8.4. Okay, so those are your absolute value. Today we're also talking about square roots. Okay, so the solutions to this, so if I wanted to solve for x squared equals k, if I wanted to solve for x, the opposite of the square is the square root. The important thing to keep in mind is that when you take the square root, you get a positive or negative. So today there's a lot of positives or negatives. On the absolute value, you get two answers, and when you square root it. Okay, so if you only have one answer, you're doing something wrong. So let's try E. If I want to solve for R, I would obviously square root this. Okay, so I'm going to get R equals plus or minus, big part there. Square root of 81 is 9. Square root of 121 is 11. So plus or minus 9 over 11. Don't worry about doing that in your calculator. Just do it separately. Do the square root of 81, 9, square root of 121, 11. Okay, now example F, you must divide by the coefficient of 18 first. Okay, you will square root it last. Okay, so you do not get to square root it until you just get the variable squared. Okay, so kind of same idea from absolute values. You always do that part last. So now that it's by itself, I can square root it. So I've got plus or minus. The square root of 5 is irrational, which means it goes on forever. So I don't want you to give me a rounded decimal. I just want you to leave it as a square root of 5. Example G, keeping that same idea in mind, okay, I have to get rid of my 1/4 first. So I'm going to multiply each side by 4 here to get rid of that. So I'm going to get m squared to equal 144. And now that I've got that by itself, now I can square root it. So I get m to equal plus or minus 12. Okay, so I've got a positive or negative on all of these answers, which means I've got 2, which means I'm doing things right. Example H just is kind of saying simplify. Okay, well, if you understand that a square root and a square cancel each other out, all I'm left with is the negative on the outside and then my inside number, which is 88.92. So to simplify it, just realize they cancel, so you just get the number underneath the square root. Same thing in I, okay, the square here and the square root cancel, so 9 minus 12, okay, is 3. Now you're going to say, well, isn't that negative 3? Well, if you actually do the whole thing out, I would get negative 3 squared, which is a 9, and then the square root of that 9 is 3. Okay, so I'm going to leave my answer as a positive 3. If you ever get a question like this, you can always just kind of take the absolute value or take the positive of that, because it's always going to work because the square will always make your negative positive. And example J. Okay, well, if we're thinking about yesterday, maybe some of you are thinking about foiling that. However, foiling that is going to make this really long and nasty. But we understand that a square is the opposite of a square root. So because this whole thing is in parentheses, I'm just going to square root it because that cancels out. And all I get then is 4r plus 12 on the left side. That's a lot nicer than if you FOIL it. Okay, if you FOIL it, you're going to need the quadratic formula, and we haven't learned that yet. So just make it easy on yourself. Okay, cancel it out right away. But remember, when you take a square root, you've got a plus or minus. So now I have two equations. 4r plus 12 equals 8, or 4r plus 12 equals a negative 8. So if I solve my first one, I'm going to get 4r to equal, if I subtract 12, negative 4. So r will equal negative 1. Or my second one, subtracting that, I'll get a negative 20. So r will equal negative 5. So there are my two answers over here. Okay. My second one, k, I can't just square root it because I don't have the parentheses. So you're really going to have to pay attention to detail here and see what the problem's asking you. Okay. I don't have parentheses, so I can't square it first. But let me see if I can get this by itself. So I should be able to add 45 to each side. So I've got 2m squared to equal 72. Then this looks like one from earlier, so now I can divide by 2. So I've got m squared equal 36. Now that it's by itself, now I can square root it. So plus or minus 6. So that works out really nice. So please take a note between j and k. There is a difference. J had a whole expression in parentheses, okay? K did not, so I could just move everything and then square root it at the end. Okay, so keep those in mind. An example L, little story problem. A square and a circle have the same area. Okay, so I'm just going to draw a square and a circle. The square has a side of a length 10. Okay, what is the radius of the circle? Well, I know my area of a circle is pi r squared. And if I know the square has a side of 10, then I know my area is 100 because you just do 10 times 10. So now if I want to solve for the radius, I could set them equal to each other. So I could say 100 equals pi r squared. So to solve for r, I should divide by pi first. So 100 divided by pi gives me r squared. And then I would square root that. So usually I would have a plus or minus here, but because I'm talking about the radius, I would only have the positive answer. So you could leave that the square root of 100 divided by pi. You could plug that into your calculator if you wanted, but let's just leave it as an exact answer. Okay, so we went over absolute values and square roots today. So stop, think, write down something you still have a question about, and bring that to class tomorrow.